Hello, everyone, and good evening. Welcome to week 5. So in this week, we'll be covering functions and objects. Objects is the starting of object-oriented programming. So we'll go through the fundamentals, and during the lab, we'll be covering the corresponding functions and objects or the class concept using mainly the hub, coding hub site. And we'll try to solve some of the examples. Okay. Now, there are some questions about the assignment. We'll probably, please remind me that during the lab session, then the individual problem, if you have any weak issues or anything, we can discuss about that. Also, if you need any one-to-one support, we can do the Zoom meeting, right? Preferably on Monday or any other weekdays if I'm available. So it should be fine after 5 o'clock, any weekdays. Next week will be the holiday, and the week after, I'm not sure, but I'll notify that. I asked the coordinator about the timing, but next week definitely is the holiday. Okay. So in the chat, you can ask any questions or anything. Now, this week and so on, and for the next weeks, we'll be doing the lab work in Colab, because in which you have to do the weekly assignment plus the the final assignments as well. By the end of week 5, you should be able to define and call the functions to reuse sections of code, define custom types of objects with classes, and understand how reference work and the difference between mutable and immutable objects. So few new concepts we would be going through slowly, and I hope it should be interesting. In addition to that, feel free to use the textbook. In the reference, you'll get the book and try to solve the exercise, try to take help from the AI tools to know more about the codings, in addition to the coding hub and the other, I think, related classes that probably you're doing. W3 schools and different websites you can take help. Okay, now in the first half of the lecture, in terms of function calls, how to write a function and what are the parameters of a function, what does it mean, what is the scope of a function, and how the return values can be accepted, and how a function can even run without any return values, we will all try to cover. Most of the concepts are pretty much popular in other programming languages because Python is pretty new language. So what really happened is that Python has more features, more flexibility in terms of even using functions and other things that will actually demonstrate. What is function calls? In general, when we write a program in Python, it is a kind of step by step. The first line will be executed, then the second line, third line. That is the conventional mechanism. In addition to that, we did last time the while loop or the for statement, right? The loop statement in which we know that, a fraction of the block of the code, a block of the code can be repeatedly executed, right? Ultimately, we can break it, we can go down, but eventually it becomes sequential execution of statements. Okay, so whatever we did, basically, you can think of, we really executed a single function. So the code structure that we really did is a big chunk of code. It is really a single function, but today actually we will try to understand that how we can give a module a structured way to call a chunk of code, right? So for example, I have a lines of code, say 200 lines, but a corresponding 50 lines of code is really important. It is doing a particular kind of type of function. type of functionality. So why don't we give a name of that particular chunk of code, right? That is the basic concept that we'll be starting. Okay, now what is a function? So a function is a named block of reusable code, which means that this particular code we can reuse. A good functions are self-contained, right? Sorry. Yeah, so it is a self-contained and accomplish a specific task. So this is the definition of good function. Now, there are some advanced concept called, for example, cohesion, coupling. I mean, this is just a kind of additional thing, but it's not needed at this stage. Just additional notes, right? I mean, which means that a function, if a function can do a very specific task that is completely independent of the remaining bits of code, then we can say that the cohesion actually improves, right? And so on. So this is basically some of the advanced software engineering term, but we just can ignore that. That's fine. Now, using functions reduces the amount of repeated code and makes the programming easier, right? So we'll see some examples. So, for example, to run the code in a function, you must call the function, right? So to run the code of a function, we must call the function, right? That is the basic idea, right? So we must call the function. So this is the interesting thing. Now, we have already been using some of the functions calls. So from the very beginning of our journey to the Python, from the week 1, basically we really use some of the functions called. For example, the print, very popular print statement, right? Also the input. And this is basically the IO thing, right? Input, output. So this is the output, and this is the output, and this is the input, right? Basically, these two are the most important thing for any programming. We take input from the user using the input statement, and we do the output into the console using the print statement, right? Inside the print statement, we know that we talked about the f string, and we can concatenate the string. If there are different types of, like one is a string, another is integer, we need to convert that integer to the str, right? We know that, and we can concatenate that. However, so all these are actually the feature of the print function. How the print function is designed, based on that, it has different type of capabilities that we can exploit when we are using the print function. And here the hello is basically the parameter. Okay. Similarly, in the input function, so this is the function. So I can write it down that this is basically is a function, and I can say that this is basically the parameter, what is inside the function, right? So this is these notations are really important in regards to the function, right? So the function name, input is a function name, and it followed by a first bracket or a bracket, right? And then the parameter. The parameter in this particular example in front of us, there is only one parameter. I mean, we can have multiple parameter and so on, and ended by another bracket, closing bracket, right? So, so inside the brackets, this portion is actually the parameter, right? The parameter. There is actually one parameter in this particular case. There is only one parameter. Okay, I think that makes sense. This is just the definition. Now, this is actually is talking about in a different way, that this is the function name. What is the anatomy of a function call, right? Function name, and these are the arguments or the parameters, first parameter, second parameter, or arguments 1, arguments 2. So we can say that this is the first argument followed by the second argument, in which there are two arguments, right? And parenthesis is enclosed with, right? So function name, the first parenthesis, and arguments 1, comma, arguments 2, and closing brackets or parentheses. So this is the structure. Okay. Yes, correct. So arguments are same as parameters. I talked about parameters because that is also pretty common in the programming domain. So I use that word parameters, same as arguments, right? Okay, so arguments, the inputs supplied to a function are called arguments, right? Okay, so Darshik, is it okay, right? So this is the same. Okay, now any kind of expression can be used as an argument. So for example, I mean, literals, for example, type 65.3, right? Or variables, for example, str temperature. So we can see here, interestingly, that any kind of expression can be used as an argument, right? So uh, you can see that type is a function name. This is the parenthesis, and this is the argument, right? This is the parenthesis. So similarly, str is a function name. So I can write it down here, and temperature is the argument, right? So I think that makes sense, right? So I'm just writing it down. So type is the function name, and this is the arguments, right? Arguments. Okay. Or it can be complex expressions. For example, print, and I think we are familiar with that type of notation, right? That under the print, we can do a concatenate operation with the plus sign, and then is there a dollar sign, and then str x2, x times 2. So x is a variable, so the corresponding value times 2. So if the x is the 100, so it should be 200, and that 200 integer that can be converted to the string. So the print output should be $200, right? So this is a kind of complex kind of arguments, right? And multiple arguments are separated using the commas. Multiple arguments can be separated using commas. If we can look at any of the function, the help file of a function, we can find that how many arguments the function can support, right? This is actually, we can see over time. Even today, for one function, I'll actually go through that analysis, right? So I think that's it. So we can see that we can put a single argument, we can put multiple argument using commas, we can put complex expressions inside a function if the function supports it. Things the functions can do. Okay, a function can cause an effect. For example, so this is the basic idea of a function, that it must do a job. It must do something. And in other words, a function can cause an effect, right? For example, the print statement, the print function, it causes an output message to be displayed, right? So that's the basic idea, that the output message will be displayed by the print function. Also, a function can compute and return a result, right? So we can see that there are two types of functions, right? One type of function is just do the job. Another type of function is that it does the job, but also it returns a value. It returns a result, right? Even it can return a list of results, right? I mean, whatever we can think of, we can imagine, right? It can return a result. So what does it mean by result? Result can be integer, result can be string, result can be any data type, right? It can be Boolean, it can be true or false, it can be a list of results, right? And so on. For example, the str function converts its argument to a string and returns the result. We know that, right? That the str function, for example, I mean, we are familiar with the str function. And if I put like 9, sorry, my mistake. So if I put only 9, so what it does is that 9 is an integer. So that integer is converted to the string. So this function is returning a string. It returns a string, right? This is the return value. Return value is a string. Return value, or, sorry, return type. Okay. Technically not a function, but we won't be able to detail here. Okay, let's say the str9, I think we are familiar with that. Now, what is the second argument in this function call? Check your understanding. So we can see that print. So I need your answer. If we can just focus on this understanding that what is the second argument in this function call? So there's a print function. Excellent. So all of many of you replied 18. So let's see. So we can see that print bracket parenthesis, and then there is a single quotation, and this is the first argument, comma followed by comma. So this comma is the separator, and this is the second argument, right? And then this is the separator, is the comma, like this comma, and then this is the third argument, right? So this is the third, this is the second, this is the first argument. Good. Okay, so 18. So print is the function name, not an argument. I, Jimbo M is the first argument. These commas are part of the string. Okay, so so we can see that these commas means like this comma or this comma. These are the part of the string, right? And years old is the third argument, right? Years old is the third argument. 18 is the second argument. Good. Excellent. Now, built-in functions. There are a few dozen functions. What's supposed to mean? I didn't understand, Darshik. What's so here, right? These you're talking about M. I, Jimbo, M. I'm 18 years old, right? So I know that it's you can try that function, but the whole thing is a sentence, right? Not the comma. So this is just a string. I mean, you just try to make a kind of sentence, but these parameters, the comma in M. Oh, no. This comma is okay. I understand your question. So what's happening here is that suppose if I write a print function, say print hi, I put a comma, right? Am I right? Right. So similarly, if I put a second argument, what I'm doing here is that print like this, the A is the first argument, comma B argument. So these comma indicates that this is a string type. It is a character type or a string type. If I don't put the comma, it will become, and if it is a number, then it will become integer. Does it make sense? Yeah, okay, right. So what I'm saying is that if I say print, say A, comma 9, right, then this is a integer. Then I don't need to put the that comma, right? That quotation, basically, the quotation mark, right? Okay. So there are few dozen functions available in Python for by default. For example, input and print are built-in functions. So this is there is an interesting word, popular word, it's called built-in functions. So built-in functions means system level functions, what Python is already providing to the programmer. And of course, the built-in functions make built-in functions make the life of a programmer easier, right? Otherwise, you need to write your own functions, which is it's really difficult. It can be done, but it's really time consuming. But any built-in functions will make the life easier. Let's check a few more. But now our focus is to, by looking at a built-in functions, we need to understand arguments. We need to understand what the return value is and so on, right? Some have advanced users that we'll ignore for now. Okay. Let's see. Now, the abs function, that is a built-in function, and it takes one argument, like a number, returns the absolute value of the number. That is, removes the minus sign, right? And you know that I would strongly suggest to I'll show you some of the thing in the, you can really take help of the, say the, the AI tool to demonstrate few things about the apps function. I'll just try to show you one thing. Of course, many of you are using it, but just to, I'm trying to make sure that, you can take help of the AI tool. So the apps function, I'm just typing in, I'll share the screen in Python. Hey, so um, I'm just sharing the screen here. Okay, so you can see here that I just typed apps function in Python, and then it demonstrates that this looks like that. It has parameters. And I talked about the parameters, right? And that's why even here it is actually common, but argument is actually in our course description in our PowerPoint slides that's used. That's fine. Okay, so x is a number. It returns absolute value of x, and different examples are given. So if I put abs -5, it will output 5. If I put abs is the absolute value of 5, right? It gives 5, and this is a Python example. In case of complex number, so you can see that other examples are actually demonstrated that probably in our PowerPoint slides is not there, but you can really search, or I can say that the help file kind of, if you want to understand a function, then these AI tools are really really useful to more about a function with the examples, right? That's really really useful. Okay, now I'm coming back to here. Okay, now abs is now clear, right? So abs is actually giving the absolute value, right? It is actually the distance from the 0 to that particular value. So absolute value of -5 is definitely 5, right? What is the distance from 0? Absolute value of 100 is 100. Absolute value of -100 equal to also 100. It removes the minus sign. What is round function? Another really, really popular, right? That we use kind of, in calculation frequently. At least the concept we are using in the calculations. However, this round function in Python, it takes only one argument, and that's a number. Excellent. So round up to the whole number, right? So return the number, round up to the nearest integer. So how it will round up? It goes to the nearest integer. So for example, you can see the example, the round 1.99, it will take 2, definitely 2, right? But round 6, same. But look at this one, -6.2 is not 7, right? It's the closest number, so which is 6. So we can think that if anything above 6.5, 6.5, so something 0.5 more than that is actually going to the next number. Otherwise, it will go down to the nearest number, right? So 6.2 is definitely close to 6, not the 7. I think it makes sense, right? So this one is really, really making. So it's rounded off to the nearest integer. uh, Even if you're not sure, you can check into the Python, right? Into the Colab to check what's really happening. Maybe I can do a quick check of one interesting thing here. Sorry. So I just going to the Colab. Um, um, just trying to share the screen as well. Um,
why we call Nabi's death Shabbat or same person, meaning the wedding night. It marks a
just going here.
If you want to learn more about Ruby, be sure to
Sorry.
read right on.
Okay. So let's put a code here. So for example, if I just put round say 1.5, right? If I do that, I hope it will go to the 2. Let's see what happens. It is just connecting. So 2, right? We can see that it is 2, which makes sense, right? Okay, so Matt, you're saying that are there ways to force it go down or up to? Yes, yes, there is. I think there is a seal function and floor function. Let me check, right? This is a really good question, right? I mean, we're not stick with the round function. Even here, that I can remember. So Python seal and floor, right? So yes, so seal function is this seal one. So you can see that now this is really, you need to import a library, math, then seal. What it does, math, are you following? So I think, am I sharing the screen? That's the thing. Yes. No, not really. Make one. Okay. Now I'm just sharing. Okay, yeah. Yep. So seal function will go to top always, right? It doesn't matter. Like 3.1 round goes to the 3. But here actually we can see that it just goes output. Does it make sense about the seal? So seal actually it goes up. Anything even 0.00001, it will go to the next integer. But the floor function, you need to import math. I'll talk about how to import the header file, right? In which actually if you put the floor, then it will go down to the output. So sometimes I know that this is really, really important, the seal and floor. Round will not perform our requirement all the time. We need this, all these 3 in case, right? Depending on the situations, right? For example, just try to imagine the, how can I say, okay, say, um, uh, divide a land among 3 people. If the land is 3.1, then definitely, I mean, the fraction 0.1, I cannot do that, right? So I need to somehow use the floor for that particular situation, right? And so on. Just, we can think of other examples as well. But this is the interesting. So seal is rounds up to the nearest int and floor rounds down to the nearest int, right? If it is just something higher or lower, whatever. Okay, I just go back to here. Okay, now I think it makes sense. The round is always going to the nearest kind of thing. Reversed function. So it takes one argument, a sequence, and sometimes I strongly suggest that you look for this function into the AI tool to know about more about this particular function if needed. Takes one argument, a sequence, returns the sequence in reversed order. So look at this loop. For I in, if I put range 5, what it would happen? From 0 to 4, 0 to n minus 1, right? So it should definitely put 0 to 4. But when I do the printout, since I use the reverse function, it will start from the 4. So 4, 3, 2, 1, and 0. Okay, so that reversed function will do the job, right? So I think that's it. So again, that's another more applications are there. So I'm just searching another thing. Reversed Python. So even in reverse sequence, it can really do a lot of things. I'll show you one more examples on the reversed function. Basically, I'm sharing the screen on that. Okay, so look at this first example, that reversing a list, for example. So what I did, I just checked with reverse, right? So reverse in Python. So it gave all the examples, all the demonstrations. So nums equal to these, reverse nums, right? So reverse is the function in which I can put a list. And then if I print that list, then I can get the reversed output, right? That we actually used in the for loop. I can reverse this string like hello. If I put that text into reversed mode, then I can output as like that, right? Similarly, the tuple data, that's another type of data of different fields, similar to a list. Right, so and then print tuple, reverse tuple. So if I do that, I can get the output 30, 20, and 10, right? Okay, and in case of reversing a range, so I put a range 1 to 6 to R. If I put the reverse, then that actually other functions. There are a lot of functions probably is there. So I just try to skip that. Now I'm going back to here. Okay, so max and min function. That's another popular function, right? So max and min function. So it takes multiple arguments, right? It takes multiple arguments like 3, 45, minus 76. I can put multiple arguments and it returns the maximum and minimum argument, right? Mean 3, 4, 5, right? Okay, so one question here, what is the function to randomize something like a text? Okay, you can, Darshik, you can ask to the AI tool, right? It will give an answer. Like there's a random function by which actually you can do that. And all these are actually under the math function, right? So I'm just trying to show you. Okay, I think it's there. I just try to put that. So max, okay, so I think, let me check into the thing, random in Python. Yeah, so random is a popular function in Python. There are many ways you can really do the thing. So random is something like a text, right? So if you know the basic function of random, then by which actually you can put a string and with the sequence, you can try to randomize that, right? Okay, now in terms of max and min, I'm just trying to go here, right? So you can see that there are 3 parameters and it gives the output, right? Now, suppose there is a number. Now the question is that how many arguments I can really put, right? How many arguments I can really put? So that number is actually big number. We can put a big list, big arguments, right? That actually is limited by the Python's call stack size or memory. So engine is a huge, right? But if you go for huge kind of arguments, we can put a big list, that is easy. But in terms of number of arguments, that's a different thing, right? Even that, it can allow a large kind of number. You can handle a large number, right? So I just got that using the AI tool. Now, evaluate function or eval, right? In short. So it takes one argument like a string and returns the result of evaluating the string as a Python expression, right? So this eval is really sometimes useful that it takes an argument like a string. We can see from here, right? Like as if we are asking like 2 times 3 plus 5.6, right? So what it should be doing. So once we do it, that expression, if we do it directly, then definitely Python calculate that. But that I can put inside an eval function, evaluate function, that the function knows that this string, this argument is basically, there's a how many arguments here? Only one argument, right? This is just only one argument. Only one argument, right? And that one argument, okay, we'll talk about that. That's okay. Why is the function considered unsafe? So we will see that later on, right? Unsafe, we'll discuss that depending on the situation. Okay, so this argument, first argument, it will take this argument, and then we try to evaluate it. That's why the eval function, and then it gives the result. Similarly, under the eval, we put the round 3.14, then it will do the round, because its round is going to the nearest integer, right? So it give the round. So return the result of evaluating the string as a Python expression. This function is generally considered unsafe. Don't use it into your programs, right? So it's generally considered unsafe. So if you look at the help, you'll find unsafe, because sometimes, there are some reasons. One of the reasons is that, I mean, some of the expressions, it can stack overflow and so on. So for example, if I just search it, and then I'll show you. Okay, so one really interesting examples are that what type of expressions we are trying to do. What type of expressions we are trying to do. So see one that I'll show you, that I'll share the screen. So I can see here, for example, I put expression 2 plus print oops, right? So definitely, you just try to imagine that you can't really do that operation, right? This operation, you can't really do that. So if you type in, then it will throw an error. So this expression, when you try to evaluate it, it will raise a syntax error or executes unwanted code. So by using that in eval, actually, a very complicated thing you can put, that can be, for example, never ending loop, for example, right? Or it is, you need to catch the error or something like that. I think this example is really good one. Injection error can be done. So there are a lot of advanced thing that that you can read on more on that particular thing. That's why it is unsafe thing. Okay, just going back. Now we're at the basic level, but so some comment came. Yep. Yep. Good. So writing a function, how to write a function, right? Okay. So in Python, the define, right? DEF is actually the shortened notation of define. Define keyword is used to define a function, right? DEF. So def and then greet. So this is the structure, and this colon is actually the body of the function, and inside the body of the function I just put the print and then hello dear user, right? So if I do it, then what's happening is that if I call this function like the greet in this way, then it will execute the function, and the execution of the function is basically printing hello dear user, right? That will be printed. Okay, so once the function is defined, it can be called from somewhere else, right? This is an interesting statement, that once a function is defined, it can be called from somewhere else. So I can call this function by calling this function like this way. Control flow. So when a function is called, control flow jumps to first statement in the function, right? So for example, here, when I call this function in the greet, it will jump to the first line of this particular function, right? And if there are multiple lines, like line 2, line 3, line 4, all will be executed one after another, right? So this is how this function actually works. When the function finishes, control flow is returned to the place that the function was called from. So suppose the greet was called, so the control is going to the function of print, execute all the lines, and then finally go back to here, the next line, right? And so on. So returns to that particular function and continuing executing from the next line. Okay, so this is how basically the things are designed, and in that process, it is the whole, all the codes are actually kind of sequential. They are executing in a sequential manner. Okay, so when a function is called, control flow jumps to the first statement in the function. When the function finishes, the control flow is returned to the place that the function was called from. The statements in a function are not executed when the function is defined. The statements in a function are not executed when the function is defined, right? When I just define a function, it is not executed. As long as when I only call this function, so suppose I write this code, it will not execute, right? It will never execute, right? So what does it really mean? Suppose just try to think about a situation. Say, suppose on the left portion, I'm just writing a code. At the beginning, I just put like a equal to 1, b equal to a plus 2, and then there's a def greet, and then print, and then if I put print b, so what do you think? What will happen? So I just write that is the line number, right? 1, 2, right? 3, 4, and then 5. These are the line numbers, right? So what will happen if I run this code? So then what will happen? The line 1 will be executed, 2 will be executed, 3, 4 will not be executed, and then 5 will be executed. Does it make sense? So because that was not called, since the greet was not called, it will never be called. So, but if you just try to imagine that after print b, if I say greet, that's it. Then line 6 will be called. So what will be the output? Output would be, so line 1 will be called, 2 will be called, 3 or 4 will be skipped, 5 will be print out, so 3, and then greet. So then it will jump from here to here, and it will be printed hello dear user, right? So this is how actually it will be excellent, right? That will be executed in this manner, right? Different but not colon. Good. So all clear, right? I think it makes sense. Okay. So look at this example. Let's look at the control flow for this program. The statements within the tick function are executed with each function call, right? So so look at the def tick, print tick talk, print who am I, who am I, then tick function is called, print I'm a clock, tick, and then print goodbye. Okay, so first it will start from here, and def tick, and then this tick and talk would be printed. So now what's really happening is that line 1, 2, and 3 will not be executed because this function was not called, right? But this who am I is printed now, and then tick function is called, so it will jump to the print tick, and tick will be printed, and then talk will be printed, and then it will go back to the original position and execute this print I am a clock. It will be printed, and then tick function is called again. It will jump to the print, and this tick is printed here, then this talk is printed here, then go back from where the function was called, and then this goodbye is actually printed, right? I think the sequence is okay, right? Just I mean, probably you can just, I'm just going through a quick review on that. That first, this function is never be executed because it was not called, right? So whoami is called, then tick function is called, then I'm a clock is printed, then tick function is called again, right? And then the final statement, the goodbye is executed, right? So this is how the sequence is executed. Don't repeat yourself. So in software development, there's a good practice called don't repeat yourself, dry, right? So dry code avoids code duplication, writing similar code multiple times. Functions are an effective tool for producing dry code, right? And so using functions, we can really, in an effective way, we can really produce the dry code, right? Um, okay, so it's basically what it is saying that, right? I mean, for example, I want to do an addition. So if I make the addition multiple times, I make a function and then call that function multiple times. So we'll see an example, then it will make sense, right? And not really loops, it is actually writing code multiple times, right? To avoid that, we need to make that repeated code in different places into a single function. Make sense? So let's say, right, example code duplication, for example. I'm just trying to make an example of that. So water, so here we can see that water is this, print covered in water, and then print str water times 100 plus %. So this is a kind of fixed pattern, right? Line 3. So line 3 is that, and line 6 is also similar, same, right? But line 4 is land equal to 1 minus water, print covered in land. So it is basically identifying the portion of the land and portion of the water. So line 3 and 6 have the same purpose, to display a percentage. What are the problems is that it is cumbersome to copy and paste. Sometimes you can have an error. Changing the way percentage are displayed requires multiple edits, right? And that is clearly error prone, right? There is a possibility of error if there is a repeated code. So that is a kind of fact that within the programming, if there is a repeated code, there is a possibility of error, right? Okay. So here we had to edit 2 lines to print percentage as round numbers, right? These 2 lines we need to do. So in a large program, many more edits could be required, and so on, right? And it is easy to forget one or to make a mistake, right? So to avoid that, why don't I put line 3 or 6, one of them, into a separate function? So what I really did here is that the first line number 1 and 2, we defined print %, and x is a parameter or argument. X is the the argument, and then print whatever argument we supplied, we passed the x, that is actually executed here, right? It's the same statement of the print, right? And this is the code. So definitely we know that line 1 and 2 will never be executed at the beginning, right? This because this function was not called yet, but it will start from the water, right? Water, it will execute, and then water variable has that value, and it will be printed. Line 5 will be printed. Then I'm calling this print % function with the water value. So then line 6 will jump here in the line 2, and that will be printed. And then it will go back, execute line 7, right? Land is calculated. Then line 8 is executed, the printout covered in land. Then line 9, this function is called again with the print % of the land. So it will go back to the line 2 again and print the %. So lines 1 and 2 define the print % function. The function has one parameter like x. Lines 6 and 9 call the function, and the code in print % will be executed with x set to the argument value. right? So with the X set to the argument value, it will be executed, right? Okay, now it's your turn. So how many times will the shown program print the output? So how many times this print will give the output? Let's see. The best thing is that you can, paper and pen, you can check manually. Um, One said 4, another is 3. Let's try to correct. Okay, 3. Okay, so so let's see, right? We'll just try to analyze. So basically 6 times. Okay. So each time, look, let's see, funky funk is called, groovy is printed 3 times, right? So I call these like line 4 3 times, right? Does it make sense? Line 2 and 3, it will be executed because there is a for loop. So there is a, sorry. So there is a for loop. So this definitely will be printed 3 times. 3 times. Why 3 times? Because i's value is 0, 1, and 2. That is the value of I. Right? This for loop. Make sense, everyone? So 3 times. So this will be printing 3 times the groovy. Right? And then line 5 is wrong, right? 5 and 6 will never be executed because 2 plus 2 cannot be 5. So this line 5 and 6 will never be executed. Then line 7 will call this function again. This function, it will jump to here again. Again, the print groovy will be happening 3 times. Excellent, right? All clear? I think it makes sense, right? Any question? Otherwise, I can repeat again. So if I just probably, right. So the first time is from line 4, it will be called for 3 times because I equal to 0, 1, 2, 3 value, right? Range 3. So this print statement will be executed 3 times. And the next time, and line 5 and 6 will never be executed, right? Because this statement is completely false. Any false statement cannot be executed. And the last one is this statement, funky funk. It will call this function again, and it will print it 3 times more. So total 6 times. Yep, excellent. Okay, now parameters, scope, and the return values. Parameters are function input variables declared as part of defining a function. So a function can have 0, 1, or many parameters. It acts like a placeholders, right? Arguments are the values assigned to parameters when calling a function. A function must receive 1 argument per parameter. A function must receive 1 argument per parameter. So parameters are function. Okay, let's see. If parameters are function input variables declared as part of defining a function, so it acts like a placeholder. So a function can have 0, 1, or many parameters, right? Okay, so let's see here that x and y are actually parameters, right? So line 1, define a function called print product with 2 parameters, x and y, right? And then when I call this function, that is actually becoming arguments, okay? So I actually at the beginning talked, kind of in the same way, but there is a slight difference, right? One is that when I define the function, this x and y is actually what? The parameters. However, when I call this function, this is the arguments, right? So ultimately they will match to each other, right? That's why, it's kind of used interchangeably, but that is the precise definition, that parameter is in the body of the function, whatever is used, but argument is when I call this function, then these two things, these two, kind of entities are called actually arguments. Okay, so line 1, define a function called print product with two parameters x and y, and 3 and 5 are the arguments. Line 4, call the print function with 3 as the first argument and 5 as the second argument. So you can see that first argument and the second argument. The order numbers, the order matters. So the order matters. This is really interesting, and sometimes we can change it over. There's a really interesting feature here in Python only. So the order matters. So for example, the first argument will correspond to the first parameter, right? So the first argument will correspond to the first parameter, and the second argument will correspond to the second parameter, right? It makes sense. So the order matters. So x will take the value of 3 and y will take the value of 5. So in general, in the argument, we put the value, and the parameters are actually the variables. Make sense? So parameters are actually the variables, and in the arguments, we give the value or a data type. For example, it can be integer, it can be float, it can be string, it can be number, it can be Boolean, right? Any data type, or it can be list even. All good, everyone? Okay. Now, default arguments, a really kind of very common popular term is a default argument. So a default argument is a value given to a parameter when no argument is explicitly provided in the function call, right? You can specify default arguments as part of the function definition. Okay, we'll see an example, then it will be clear. So, for example, here, the default arguments, right? So, I'm defining a function print ticket. So, how many parameters? So, age is the first parameter. Max child age equal to 12 is the second parameter. So, I'm putting a variable with a value assigned. So that is actually the default arguments, right? Default arguments. And if age is less than equal to max child age, then I'll print it is a child, else print full fair, right? So diff print actually give a output. It will print something, right? So what's happening here is an interesting statement that print ticket, look at the first line, print ticket 5. I'm only passing one argument, right? One argument. So this 5 will correspond to age. And the second parameter in this particular function is actually fixed value. Max child age equal to 12. It is fixed. I can't change it. And that's why this second parameter is called default parameter. So you can imagine that that when I call this print ticket, then that 12 is already embedded as a second argument. That's why I don't need to put that into inside, right? And print ticket 15, it will put, full fair, and print ticket 15 and 18. So what's really happening in the third line? It's really, really interesting concept here. I'm actually providing two arguments, right? This is argument 1, argument 2. So argument 1, 15. So 15 goes to the age, right? It goes to the age. And the second argument is actually 18. So the second parameter's value is actually 12, but that 12 will be replaced by the 18, right? So what do you think in that case? What's happening here? What's happening here is that if you go inside the function, when the first age is equal to 15 and max child age equal to 18 right now. So age is definitely less than max child age, and this print will be executed. So child will be printed. All clear, everyone? Yes. Yes, Darshi, yeah. Max child here. So here basically these second argument, so max child age is changed. When I explicitly put a value, it will be uh, no, no, it's a default argument. So not fixed, not constant, right? Default arguments means that you can just try to imagine a flexibility, right? Suppose, I mean, just try to imagine, suppose when you buy a car, there are some default, the features are already there. So those values are already there. But if you want to modify the value on that particular corresponding variable, you just put a new value, right? So it's not a fixed one. Default means that if I don't put any value, that variable will take a default value of 12. So in other words, if I, right? So yeah, I think it makes sense now, right? So if I type like print ticket, sorry, print ticket, and then if I put say 100, just only one parameter, then the age is 100, but the max child age is 12, right? So because I'm not supplying that value, that's why max child age is 12 all the time. But if I want to change it, I can put the second argument, right? So what I can do is that I can just simply, put something like, say, 102. Then max child age, of course, this is an unusual value, but then the max child age would be 102, right? They would be same. So, so what is the summary? The summary is that when I put the second argument, then the parameter value, second parameter value, is changing from the default value to the new value. So it is changing now, changed from default to a new value that is supplied. Does it make sense? Yeah. Okay, so it changed from the default value to a new value that is a supplied value, which is 102, right? So that basically is happening. So default value is not a constant value. What is default value is a value that if I don't put in an argument, the function will treat the default value that is defined within the function parameter, right? Otherwise, it will override. Okay, we'll see more examples in the future. Beware, once you specify default argument for one parameter, all parameters which come after it must also have default arguments, right? So once we specify default argument for one parameter, all parameters which come after it must also have default arguments, right? So what's really happening here? So to do something A be equal to 1 and C, so pass is doing nothing basically. So no default argument follows default argument. So master default argument. So which means that when I put the first one as a default argument, then C, it must also have a default argument and followed by all the things, right? Right, yeah. So no, not A doesn't need default argument. So what it is saying that all which come after it, that is the sequence, right? So for example, if I have A, then B equal to 2, then C and D, it is wrong. So C must have a default argument, D must have a default argument, which in other words, what we have to do is that we have to do like C has 0, D has 0 or 1, we have to do something like that because we defined the default argument here. Makes sense, I think, right? Okay, good. So this is actually explained here. named arguments. So these are the different features of Python, right? In a nutshell, actually, you need to revise and accumulate everything in the concept. So arguments can also be specified by name. Arguments can also be specified by name. These kinds of arguments are called named arguments or the keyword arguments. The order of named arguments doesn't matter. All named arguments must appear after positional arguments. Okay. So, for example, define, divide, num, and denom, right? So print num divided by denom. So that is what the program, this function is doing. So for example, if I call this divide by 5 and 2, so definitely it will print the result, right? Which is 2.5, right? So if I do that, look at that second line, like this one, that denom equal to 2 and num equal to 5. Now, did I change the sequence here? The answer is yes. I changed the sequence. That's why I need to explicitly define the denom equal to 2 and num equal to 5. But the sequence is different. This is different sequence. So I'm using the same parameter name, right? So the Python will know that I put in a different order, but this is what I'm trying to indicate. That I try to indicate that the denominator is equal to 2 and numerator is equal to 5. So it will adjust and do the calculation. So this is a really powerful feature of Python. Hardly in any other language that features are available, right? But sometimes any program language can improve day by day, but Python has that feature. What about this one, the third one? So I define denominator as 2, right? Then definitely the first one is the numerator, right? So this one is 5. So 2.5 makes sense. Okay, the last line, divide num equal to 5 and 2. And it is showing error. Okay, let's see. Who can answer me why it is error? Anyone? Why this is error? I think we discussed that last slide, right? Only one here. So because once we start the naming, may put a default argument, the next one must be defined as default kind of thing, right? So we have to put denom equal to 2. Denom equal to 2. Just one value can't do the thing. Okay. So we have to put that. Only one argument is named, right? So we need to do that. In most cases, you will not need to use named arguments. If you think that they will make your code more understandable, go ahead and use them. Occasionally, you will encounter functions that do actually require named arguments. We won't see many in this subject, so it will be pointed out to you when we do. Okay, scope. A function's parameters and variables defined within the function are not accessible outside of the function. This means that there is separation between code inside and outside of the function. So a good thing, this makes code less confusing. The scope of a variable is the region of the code that is accessible from. So that is actually interesting concept. What is the scope? That how far a variable can work. So we'll see from function point of view, right? Okay, so here, suppose I try to define a function, define double number x and y equal to x square, right? And double number 5 and print y, right? Print y. So what's happening here? So just try to understand that x is the the argument, right? So this is the parameter x and this is the argument 5. So x equal to 5, but the y is defined inside the double number function. So the scope of y is only within this function, not outside the function. Does it make sense? So the code outside of double number can't see x and y, right? Can't see x and y. Both are actually inside the double number. So it's as if those variables don't exist. As a result, the line continues. So when I'm putting that print y, y is not found, right? That will show an error. So that's why this error is actually happening. I think it makes sense, right? And in another term, actually, these are actually called local variables. So local variables means actually it is local. It is, from outside world, it cannot be accessed. It cannot be accessed. Only within the function, you can actually print x and print y or do any operations. But from the outside of this function, you don't have any option. You don't have any, means to use that. Return values. If a variable created inside a function are not accessible outside it, then how do we get the result of a calculation performed inside the function? So answer, use the return value. Okay. So this is an interesting thing that because a function can do some things, but if it doesn't return it, I cannot catch it, right? If it returns, then I can hold it, right? So I need some return value here. So we'll see an example. That's why we use a return value. A function can have a return value, which is a value from inside the function, which is returned to the caller of the function. The function call will evaluate to the return value. We have actually already used several functions with return values. For example, abs minus 3, it evaluates to 3. It's as a return value, right? We can specify which value is returned from a function by using a return statement, right? We'll see. If I look at a demonstration example, it will be clear. Now, return statements. A return statement can only be used inside a function. In Python, a return statement consists of the return keyword followed by a value to be returned. So this is how I can write. So return and then a string, a cool result. It is returning any string, right? Or return x plus 1. So when I put x plus 1, that expression is evaluated. So the value of x, if it is 10, 10 plus 1, 11. So 11 will be returned as an integer, right? So when a return statement is encountered, function execution finishes and the specified value is returned to the caller, right? It will be returned to the caller. So look at this example. Same example that we demonstrated before. So define double number x. X is the parameter, one parameter, and I'm doing y is a local variable y equal to x square and return y. So when I enter to this function with a parameter with an argument 5, so I'm typing it double number 5. So x is now 5 and the calculation would be done, which is 5 square, 5 times 2 equal to 10. So return 10, right? So that 10 would now be assigned to the z. So when I do the print z, it will evaluate and give the result 10, right? So it will be printed 10, right? So this is what is really happening, right? That's why this return y is doing the job, right? Makes sense. Okay, just a tricky question. Just a tricky question. I mean, uh, how can I print the value? I mean, is there any other way to do that? So for example, I can put that line inside here, and then I just call this function, right? I just call this function. Make it clear. So what I'm saying is that, so for example, if I just click the double number, I think we did that before. Sorry, I don't need to do it here. We actually did that last time, right? Like we can, so just if I call the double number 5, And then, so here basically, if I just do here print y, right? I really don't need that. Then actually, what do you think? Will the program is this a successful program? What do you think? Anyone? So maybe I just type it again here. So what I'm doing is that I'm just typing here print and then y. So can you tell me that is the program okay now? So the whole chunk of code, is it a successful program? Will it run without any error? Anyone? Yes, it will run, right? So it will just simply print. So that's the solution, right? Which means that you can basically call a function, and if the function can do all the printout, then your job is done, right? But we are discussing another thing, is that we need to return the value so that I can hold the value, I can do the job. Okay, now finishing the function execution early. After a return statement is encountered, the function finishes immediately. Statements which appear after the return statements which appear after the return statement will not be executed. So in a function, return should be the last statement. It should be last statement, right? So after return, actually, if you put anything, it will not be executed. This is similar to the continue and break. So you can imagine the return similar to the continue and break loop that we discussed last time, right? So that is, we discussed last time. So we know the continue and break, just immediately skip and go back, right? In generally the break, it just kills everything. It just goes back to the end of the loop. The return keyword can be used by itself to finish a function without also return a value. Okay, so this is an interesting statement, that a return keyword can be used by itself to finish a function without also returning a value. Okay, so what is the output of the shown program? Can you please try? If do something n, if n is less than 0, return 0 and return any score. There are two returns we can see from the code, right? And print do something -4. So what do you think? What should be the output? Anyone? What should be the output? 0, right? Okay, so actually answer is 0. So what happens is that so 1 to line 4 will never be executed, right? Because it's a defined function. But when I do the line 6, then it will jump to here. So I put the argument -4. So n equal to -4, right? N equal to -4. Now, if n is less than 0, yes, return 0. So the program will immediately return 0. So after the return 0, you don't look at other things, right? So it will return 0 and go back here, and that's it. So, you know, this is just, so do something is returning 0. So that will be printed. So 0 is printed basically, right? Good. Line 4 is not reached. Line 4 is not reached. Okay. I think we covered a lot of things. Now I would like to give a 10 minutes break, and then I will start the next topic, which is the class or object concept, right? So a kind of 10 minutes break. Okay, now I'm starting with the objects, the concept of objects. We already finished the functions in the videos. Now the objects. Okay. So far, the types of data we have worked with have been defined for us. For example, floats, integers, strings, etc. However, we might want to define our own types. For example, a student. So we are now trying to defining our own kind of data types. So define our own types. For example, I want to define a student type, right? That holds a name and an ID. So it is just holding probably multiple things. So a student can hold a name, ID, address. Also, it can hold functions, right? Like his registration function, his examination procedure. For example, I mean, so it can be really complicated thing inside a fixed data type, right? So that's the concept we'll try to build. So in this lecture, we'll learn about the objects and how to create our own types using the classes, right? How to use the own types using the classes. Okay, let me just do one thing about the chat. Okay. So the structure is the object, creating class, reference, and mutability. All these will be discussed here. What is object? An object consists of repeated piece of data, its value, related piece of data, its value, like the, for example, the student name, student ID, student address, all these are related piece of data and corresponding value. And functions which use or manipulate that data. It is called methods, right? So the object consists of two things. One is the data and its value, and the functions. That is, an object knows the stuff and can do stuff. It knows the stuff by using the variables and can do the stuff by using the functions, right? In Python, almost everything is an object. For example, integers, strings, floats, booleans are all objects. If a variable can hold it, it's an object. So if a variable can hold it, it's an object. Date objects, the first example, the date object. So we are going to use dates as an example to explore the objects further. Okay. So in Python, I'll actually go further on that particular objects because in terms of objects, it's really important to know the help file. I think the sound and everything is okay, right? We're actually going through very important discussion after a while. Okay, so in Python, dates are part of datetime module. Okay, so it's a new kind of thing, datetime module. And this is the concept of libraries, right? Or a package in Python, right? We will be using that. So the following line of code enables the creation of new date objects, like from datetime, import date. From datetime, import date, by which actually we can use from datetime module, we can import this particular object, and then we can use its properties easily, right? We'll see that. We'll learn more about importing modules in a future lecture. Okay, so a date has, so creating a date object. A date has three key pieces of date, like the year, the month, and the day. So it's a bit like three variables in one, right? So you can imagine that you could picture the date object represented by 21/7/2022 like this, right? There are year variable, it has 2012 value, month variable, it has 7 value, day variable, it has 21, right? So it's a bit like three variables in one place, right? The action of creating a new object is called instantiation. Instantiation is the act of creating a new object. So we'll see an example, right? Okay, so creating an object. The code for instantiating a new object is similar to a function call. It is similar to a function call. the instantiated object is returned. For a date object, the arguments are 3, right? Year, month, and day. Year, month, and day. So look at this example. So I think I should explain in Colab this particular portion. Just sorry for that. I'm just okay. Trying to open the okay. So if I share the screen, okay. So you can see here that this is the option I have written, right? From date time, import date, my date equal to date, and then put 3 arguments. First is the year, this is the month, this is the day, and you just print the my date, then you can expect that. So it is now changed. Now the same line you can actually use in this way. So import date time. So if you do the import date time, it is actually a different way. So you just import the package, and then so when you import the date time, all the corresponding objects inside the date time. So how many objects are inside the date time? You can actually search that in Google, right? Or in AI tool, it can give the list, right? So all are actually now inside your, you just imported everything, right? Then you can use directly datetime dot date, right? Datetime dot date. So which means under this module, use this particular object date and use the parameter, and that value would be returned to my date, and then you can print my date. You can print my date dot year, my date dot month, my date dot day is a fixed. So how many functions or variables are there? That also we'll try to explore in kind of AI tool. That will actually give more ideas, right? So if you just run it, you can get all corresponding values, right? And so on. Okay, now I'm just going back to here. Any question you can ask me if not sure, because it's a bit of advanced, so you can ask me in case any concept needs to be revised, or I can explain again. Okay, so this is a way in which a date object can be created, and my date is actually holding that particular object, right? So it has that complex kind of thing, right? That object is actually put here. Okay, so if you type the type my date, remember the type function, right? In the type function, if you could put any integer, it would return what is the data type. But in this case, it would return datetime.date data type, because my date was created using the date class, right? Date class inside the datetime module. So it will be shown when I put the my date, that is my own variable, which is the object, because any instance of the class is called object. Any instance of the class is called object, right? So I can write in this way that an instance of a class is called an object. Okay, so that is the basic definition. So an instance of the class is called an object. So I can say that these So an instance of the class. So the class is actually the date, right? And the object is now my date. Okay. So this object, my date is an object, and date is a class. This is a class, right? And this is a particular instance, particular type of instance. So if I do another example here, for example, that my date 2 equal date, say 2020 to 3. That is another instance. That is another instance, right? So then my date 2 is another object that is, keeping another value set of this particular class named date, right? I think all clear, right? This is what he's talking about. Okay. So if I put the type my date, it will give you the exact kind of class structure, right? And so on. How to access to the object data? How to access to the object data? So for example, I already created the my date, which is a kind of date type of class. Then the question is, if I put my date dot year, dot month, dot day, so how many components are there, right? So these are called attributes. So a variable inside a particular class is actually called attribute, right? So I'll actually go through an example, then it would be really clear what I'm trying to say. But these are actually the attributes. So different types of objects have different attributes. What is function? So in some of the class, there are some internal functions. So a method is a function attached to an object that has access to the object's value. The methods on my date are accessed in a similar way to attributes. So there is a method inside the date class. It is called is or weekday. So is or weekday is so the is or weekday method determines which day of the week the date falls on. So apparently 21/7/2012 was the 6th day of the week, Saturday. So from Saturday actually starts, right? So this is how actually the ISO weekday will find the number within that particular week, right? Any question, anyone? I think we'll see some examples in a very simple manner. So what's the point? So grouping related data or value and behavior or methods, right? So grouping related data and behavior or the methods, right, makes the code more manageable. Instead of keeping track of multiple different variables like year, month, day, we can bundle them all together. We group them all together. We also have easy access to the related behavior. For example, is a week. So is a weekday. So this is a function, this is a method, which means that we can say in this way that a class, so inside a class, there are, value 1, value 2, value 3. So any value is associated with a variable, right? Then there is a method 1, method 2, method n, right? All these are grouped, even there are value n, right? Whatever. So definitely when we are looking for a built-in class, which is the date in this case, we really want to know what are the values are there, what are the methods are there, so that we can use them readily, right? So that is one of the target at the beginning level, right? So this information will give us more choice, more strength to do a robust programming. We can actually then do many things, right? many things, even that beyond our imagination sometimes, because most of the functions are actually improving, right? So on. So I think this is one of the point. Now, creating a class. So we'll come to that point with a practical example after a while. But what is a class? So a class is a template. So actually we define here the class structure, right? So similar. So a class is a template from which objects are instantiated or created. Okay. So a class is a template from which objects are instantiated or created. So a date class describes what a date is. That is, it is a year, month, and a day, right? A date object describes a particular date, like 2/17/22, right? So this is the interesting kind of definition. So if we look at this example that we discussed here, that my date, it is a object, but this particular date is a class. So this is a class. This is object one. I can say why it is object one, because this is a particular instantiation of this particular date, right? Of this particular value. But my date 2 is another object. I can say that this is the object 2, but date is still fixed, is still the class. But that class has a different set of value for which the object 2 was created. Does it make sense, everyone? So based on different parameters, actually, we are creating different objects of the same data type, or here the data type is actually the class of the same class. So my date is a class, its class type is actually date. My date two's another next object is a different object, but its date, sorry, its class is the same data type, which is the same class name date, right? So this is what we are talking about. Now, creating a custom class. We're now trying to create a custom class. So the date, which is coming from the the date time module, all these are built-in class. But now we are trying to create our custom class. So in Python, a class is created using the class keyword. By creating a class, we have a custom template which we can use to instantiate objects. Let's create a ellipse class that has a width and a height, right? Okay, so just a kind of break about this particular date class. I'm talking about a structure that we already looked at: year, month, day, and ISO week, and so on. I'd like to jump and show you so that you can use by your own way to understand about the built-in function. And that technique is really important for all of you at the beginning level, so that you can know more about the function. So I think I took a note here. Sorry. Just trying to find. Okay. So class on Python. Okay, so I just show you what I'm doing. You can also do exactly the same thing to know more about any particular built-in class. So, so you can see that what I typed is variables and methods of the date class Python. And then I can see that this is how actually we can import a particular date class. And these are the variables, like you can make an today, by which actually today's date is actually imported. So today.year, or you can imagine that once you create a object, its corresponding year is one attribute, right? Is attribute is year is an attribute, month is an attribute, day is an attribute. That is actually discussed in our PowerPoint slides. Also, there are some methods like today that will print out a format like that. From timestamp, we can print out the timestamp. Format is of, which format, you can change the format and so on. That is a different discussion. And also replace week of the day is a week that we already know. We already discussed. Times tuple, C time. So there are a lot of functions, min, max, you can have a look, and there are a very good example is actually given. So all these really, improve the level of understanding that, and based on that discussion, we can actually use the date function to do whatever is required to do in our problem, right, in our program. And all this code you can copy and run it into the Python to get the idea how these built-in class is doing. Okay, any question you can ask me, but I'm just jumping back to the custom class. That is our focus. How to create a custom class. Okay. So first we'd like to create a, we'd like to create a class which is called ellipse class that has a width and a height, right? The width and the height. So the first thing that we need inside this class is actually an init function. So an init is called constructor. So that is a default function. So the code in this constructor will be run every time an ellipse object is instantiated. Ellipse, right? So an ellipse object is instantiated, then every time this will be called. So look at this structure. So behind the scenes, Python will provide the object instance as the first parameter or self. Okay, so this is the structure. So class ellipse. So define init and then the self. Self is itself, right? Self.width equal to 2. Self.height equal to 1. Okay, I just want to give a 5 minutes break. So I just have to come back. Sorry. Okay, so we can see that we can call this init or constructor function with the self, and then self.width. It means that inside this particular class, there is a width is a variable whose value is 2, and height is another variable whose value is 1. So I need these two variable, right? So that will be called. So when instantiating an ellipse object, so when I create an object of this particular class, two variables called width and height will be attached to it, right? So this is an interesting statement. These two variable will be attached to it. We call width and height as instance variables. Okay, so that's called instance variables. Width and height will initially be 2 and 1 respectively, but later we can change it, right? We'll see the mechanism, but that is actually, you can see, you can define it as a default variables. Sorry, default value of those instance variables, right? 2 and 1 is the default value of the instance variables. Okay, so when I call an class ellipse and define it as an ell, so this is the object. So I can say that if I put the type, then I can find this is a main ellipse, right? Ellipse is a type of class. And then if I call L is the object dot width, by which we can access to the corresponding instance variable, by which by the name of the object. So by object name dot instance variable, right? Sorry, instance variable. We can really access the instance variable inside the object. That is actually done here, right? So object name dot instance variable. So L dot width. So L dot width equal to 3, by which actually we are changing the default value. So by default, the L width is actually 2. So when I put equal to 3, then L width new value becomes 3, right? Okay, so this is the idea, right? Now let's see constructor arguments. Okay, constructor arguments. So if you were to call on ellipse again in future code, would it still be 3? No, it's a really good point, right? So which means that how you can call an ellipse object by creating a new object, right? So create call the class to create a new object, then definitely the value would be 2 again, right? It would be 2 again. It would okay. Is it okay, Darshik? I think the value would be 2 because if you call it again, right? So let's really look at an example later on, but maybe let's see. Wait, ellipse. So just trying to do something here. Let's see. Okay, so here if you see this code that width equal to 2, right? Width equal to 2, right? So suppose if I do L dot width equal to 3, right? And then if you type in, then you can do the 3, right? Now, if you just put these code again, right? So L2, we are making another, sorry, 2, right? So just you don't need anything basically, right? So L, you don't need that. L2, right? So you can see the difference, right? Is it okay? So this is how you actually can experiment, right? What's really happening, and it makes sense. So I mean, after a while, we'll show a picture, then it would be really clear, right? What we are trying to analyze. But thanks for the question, really good question, right? Because if we call it again by this way, we definitely need to create a new kind of ellipse, right? So this is completely a different location. This is a completely different location. So using picture, it will be really clear, right? We'll see very soon. We'll show that. This object is really powerful thing, right? So we need to focus on that. I mean, I really appreciate this type of question. Okay, now I'm just going back to the object. Okay, so currently we want to create an ellipse with a particular width and height. So we must instantiate an ellipse like this way and set the width, set the height. So to make things simpler, we can rewrite the constructor so that the width and height can be passed in as an argument when instantiating an object. So just imagine that there was no kind of parameter, right? But we can put some parameter here, right? We'll see that. So look at that. Class ellipse, so constructor arguments. So when I put some arguments that we need to put inside the constructor as well. So what is constructor? Constructor is init, right? We know that already. So in the init, previously it was only self, but now I'm putting W and H. So W stands for width, height, or you can put width and height, whatever you like. So self.width equal to W and self.height equal to H. So you're now putting the parameters inside the instance variable. So this is the instance variables, and these are the arguments or parameters, right? This is the actually the parameters in this notation, and these are the arguments 5 and 7. We know already. We know that, right? In the function discussion. Okay. So when I call L equal to ellipse 5, 7, then L width equal to 5, height equal to 7. So you can imagine that this width can be accessed, right? Can be accessible, right? So this W and H is just parameter. It is just taking the value and putting inside the width and height. But the thing is that we now are passing the arguments to create an ellipse, right? This is really convenient way compared to here, in which we need to explicitly define, but with parameter we can define it inside the constructor. Does it make sense? It's a bit of unique way, and this is one of the best way to define a constructor, and then we can create different ellipse object very easily, just passing the parameters, right, with different values. What is a method? A method is a function which is attached to an object. So already we saw a init method, right? We already saw that init, right? So this init method was already inside the ellipse. So this was the default kind of method inside the class. How to create a method? Additional method, right? So how to create a method? So already the define init is there. So that is by default, in which we can, and now we can actually initiate, we can initialize an ellipse with width and height, and then definitely with width and height, we can use this formula to calculate the area, pi into w into height. So the calculate area of an ellipse is basically pi times w times height. So this is the area of a ellipse, right? Okay, so what we're doing is that we are defining a next kind of method, like define, calculate area, and self, right? No parameter I need. I just self is the kind of self, its own definition. Return pi times self.width, because self.width is an instance variable. Remember, any instance variable can be accessed within that class. Any instance variable can be accessed within all the methods of that particular class, right? So self.width and self.height, right? Now, how to manage the whole code, right? So I'm creating an ellipse 5,7, and then I create l.calculate area, it will be printed. So I'll show you in basically in Colab the execution. So here you can see that so this is the width and height. Start coding area. I think I did that. No. Okay, I deleted that. Okay, so if I just copy that thing, just trying to, or maybe I'm just trying to define here. So what I can do is that I just define calculate area, right? And then probably return 3.14 times self dot, it's automatically coming in height times tab self dot width, right? That's it. So return an area, calculate area. If I do that, it should be fine. So I just run it, and then I can see the area, right? It is printed fine. Okay, so this is how basically we can run inside the Colab. Any question or any, you can just try to, during the lab, we'll try to run few functions. Again, today, actually, up to the 8, probably I'll be finishing, then we'll start the lab. Okay, I'm just going back to the object. Okay, now the method arguments. A method can accept additional argument after the self. A method can also modify instance variables, right? So this is interesting. It can also modify the instance variable. Let's add another method to the ellipse class for scaling the size. Suppose I want to put a function by which I can scale. I can scale both width and height in the same ratio and so on, right? For example, look at this class ellipse. Define the usual width and height. This is a calculate area. Now there is a function called scale. I put an argument, the first argument as s. So what s does is that every width are multiplied by the s to scale up or down, right? So if I put s as 0.5, the width and height will be half. If I put 0.25, it will be 1/4. If I put 2, it will be 2 times more, right? I think makes sense, right? This is the scaling factor. Okay, let's apply that into the coding. So for example, I'm putting a class of ellipse with 3 and 4 is the width and height. So sequence, I just maintain the sequence. So this is width and height, and then ELL is the object, and then I'm calculating the area using the formula. Now I'm putting the scale. So when I put scale.2, ELL.scale.2, so look at that here. So I'm putting the scale. So you need to be, it's case sensitive, the spelling and everything should be right, and put the S. I made it 2. So when I supplied 2, the value 2, width and height would be 2 times, right? So whatever width and height was instantiated, it will be 2 times. So it was instantiated by 3 and 4, so definitely 3 would be 6 and 4 would be 8. So when I put L dot width, I expect 6. And when I put L dot height, I expect 8, because both height and width are scaled by 2. And when I do the calculate area, it will calculate by pi times 6 times 8, which is 150.79, right? This new value is scaled up. So this is how actually using a method we can change the value of the instance variables, right? Notice the scaling. Notice that calling the scale method changes the width and height of our ellipse object. This changes the value returned by the calculate area, right? Can I ask a question? What are the instance variables of the box class? What are the instance variables of the box class? You can just write the names. Very simple. What are the instance variables of the width and height? No. Instant variables. These are the parameters, right? So it should be area and the full. Yeah, correct. Right? Area and the full. So remember that instance variables is area and the full. That can be accessed from other functions. So for example, if I, so why it is important? So suppose if I define another function like f2, another function, right? I mean, f2, another function, then actually you can use self area, right? Equal to 100. You can actually use this instance variable inside another function, right? But you can't really use width and height into other functions, right? I think it makes sense, right? So these you can try in experiment. I mean, that's a really good thing. Okay. Now, reference and mutability. So once we go through that particular section, then some of the concept would be clear, right? What is full? Oh, so full is just a false. I mean, just a Boolean kind of value, right? Just, suppose it is full, it's probably, the text full, like the ellipse is full, like text, sorry, the colored is full or empty kind of notation, right? Just, we don't know, but some Boolean variable to denote some idea. It can be in a color, like the full color, or it's empty, there is no color inside. Then it can be true, it can be false, and so on. So it's a Boolean value. Okay. Now, is it okay? Yeah. Okay. So every computer has a memory. So now an kind of fundamental concept we'll go through, because that will clarify some of the concepts of mutability and also some of the concepts of, how the value can be changed inside the object. Every computer has a memory. RAM is a random access memory. Memory provides a temporary storage area for programs to store objects, right? So when we run the program, in memory, actually everything is happening. So when the program finishes, the objects in memory are no longer accessible. So this is a really interesting thing. And so when something is not no longer accessible, something, then there's a concept called garbage collector. So we'll see some of the concept that was introduced in the Java. In Python also same thing. We'll talk about that. Okay. References. So far we have considered variables to be like boxes which hold objects, right? But this is not strictly true. So in reality, the objects are stored in memory and the variable references those objects. So we'll see what does it really mean. So this is basically the object concept. A variable can only reference one object. The same object can be referenced by many variables. Assigning an object to a variable causes the variable to reference this object. It doesn't copy the object. Okay. I mean, if I show the picture, it would be clear, right? It's not that difficult. It would be clear. So look at this picture. So a equal to 5. So when I execute that, I think we discussed during the debug, but that's fine. We'll explain here clearly. So these are not really, these are actually simple variable, right? I mean, but we found today that all these variables are actually class, right? So same concept. That's why the reference and the objects and reference is coming here, coming into action. A equal to 5, it looks like that. So when I say a equal to 5, a is a reference. It is pointing to an object called 5, just a value 5, right? So the integer 5 is assigned to variable a. So a now references the integer 5 in memory. Okay, so a in the memory, there is a location. I mean, it's the value that location holds a value 5, and that is pointed to by a. So a has basically an address, right? Which is actually pointing to a. Now, when I say b equal to a, b is a new variable, right? So it looks like that. So b is a new reference. So we are using the term reference, right? It is now pointing to that value that is pointed to by a, right? So when I say b equal to a, and it is now saying that b is now pointing to that value that is referenced by a, right? And now next line, c equal to 7. So c is another reference that is pointing to another memory location of 7, right? Not location, is a value. Another location which has a value of 7 that is pointing to. Now a equal to c. What it should do? That the value of a will now point to 7, right? Because a equal to c. So c is pointing to 7. So definitely that will be assigned to a. So it is looking like that. A equal to c means a is now pointing to 7. Does it make sense, everyone? It's a bit of, I mean, if we draw the picture, then only it would be clear, right? Otherwise, it's really sometimes, hard to track. But once we do it, what we can see that everything is fine, right? So A is now pointing to 7, C is now pointing to 7, B is now pointing to 5. Okay. Now, what can happen in this particular mechanism, right? That objects without reference can happen. Okay, we'll see an example. So an object can only be accessed if there is a reference to it. That is, when there are no references to an object, that object is no longer accessible by the program. So Python will automatically remove the objects without reference from the memory. This helps to free up space in memory. Okay, we'll see an example. So b equal to 0, right? So now what's happening is that was the previous thing, right? So remember that we already ended up here, right? So this is the memory situation. And then the next line, I'm writing b equal to 0. So when I say b equal to 0, then b is now pointing to 0, right? So when b equal to 0, then you know that previously b was pointing to 5, but now 5 is not referenced from any place. So it is a kind of similar to an island or without any reference. So this object of 5 is without any reference because all the three references are pointing to something else. So this is completely free. So that free object without any reference is basically useless because that is not used by anyone. And that is actually when something is not used by anyone, that is similar to a garbage, right? That's why this term came called in Java that the garbage collection, right? All the, the objects which are not references by anyone, it is just kind of unused values that can be deleted, right? That can be deleted, and that space can be used for something else, right? So that is called a type of efficiency by the program, right? Operating system actually do that thing. Okay, so the object can be automatically removed by the Python. So Python regularly remove all the objects which are not referenced by anyone to efficiently handle the RAM, because RAM is really vital space. Because if there are a lot of unused portion filled up with the objects without references in the RAM, your spaces are used up, right? It will create the chaos. It will result in less space, and the program would be slower, right? Anyway, that's a completely different discussion, but any question on that, ask me, right? Okay, summary of the references. That objects are stored in memory. Variables reference objects. A variable can only reference one object. The same object can be referenced by many variables. Assignment can be used to change which object a variable references. Objects with no references are inaccessible, right? Immutable object. I again want to give a quick kind of break. Okay, now immutable objects. And immutable, so I think this concept that we discussed is really important, that over time, what will happen is that any reference is actually pointing to an object in the memory, and some of the object may end up not being referenced by anyone after a while, and that is that the Python will try to remove after a while, right? To free up more spaces so that those space can be allocated by other references, right? So by execution of the codes, that type of situation can happen. Okay, now immutable object. An immutable object cannot have its value changed. Before this lecture, all the types we have dealt with have been immutable, like int, str, float, etc. When using immutable objects in a computation, a new object is